right, we're now going to use the quotient rule to derive some of these functions. We just talked about this a little bit in sixth period today. These are functions that once we've derived them, which you should have done with Ms. Radke, you can go ahead and have them memorized. Once they're memorized, these kind of, all four of these rules here, once they're memorized, you don't have to show the differentiation process each time. It's understood that you know that the derivative of tangent theta is blah, right? So first we actually have to differentiate them to find them. The good news is if you forget them on AP test day, you could still differentiate them using quotient rule to figure out what the derivative is. Will you have time to do that multiple times? No. So you really want to have them memorized because you're not going to have time to derive these each time. All right, what is tangent theta? Here is tangent theta is sine theta over cosine theta. And so we're going to use the quotient rule to find the derivative here. So we've got the derivative of the top would be cosine theta times the bottom. Whoops, not sure where that parentheses came from. Minus the top times the derivative of the bottom. What's the derivative of cosine theta? That's negative sine theta. All over cosine theta squared. All right, so this is cosine squared theta. Minus times minus is plus sine squared theta over cosine squared theta. What is cosine squared theta plus sine squared theta? 1 over cosine theta. And 1 over cosine theta would be secant theta, so this is the same thing as secant squared theta. So now, if you can remember on test day, derivative of tangent theta is secant squared theta, you don't have to go through that process to figure out what is the derivative. And you are going to need to be that fast when it comes to AP test day. If you forget 1, you might have time to overcome that, but forgetting more than 1 is going to be really, really hard day for you. All right, cotangent theta is cosine theta over sine theta. So for my derivative, it's not want to erase that piece. There we go. For my derivative of cosine is negative sine times the bottom minus the top times the derivative of the bottom, which is cosine theta, all over the bottom squared. So this is negative sine squared, because I have 2 of them, minus cosine squared, because I have 2 of them, all over sine squared theta. What can I factor out of that? They both have a negative, so I'm going to factor out that negative sign, because then I'll have sine squared theta plus cosine squared theta. What is sine squared theta over cosine, or sine squared theta plus cosine squared theta? That's 1. So this is minus 1 over sine squared theta. What's 1 over sine theta? That's cosecant theta. So this is minus cosecant squared theta. And that is the derivative of cotangent. All right, secant is the same thing as 1 over cosine. So our derivative here, derivative of 1 is 0. Times the derivative of cosine is negative sine minus 1 times, oh, I just did it again. Sorry. Derivative of 1 is 0 times the bottom minus the top, the top times the derivative of bottom. What's the derivative of cosine? This is 1 with the negative sign. All of this over cosine squared theta. Well, this piece is just going to be 0. This is negative 1 times negative would be sine theta over cosine squared theta. I'm going to put 1 cosine theta here, put the other cosine theta next to it, multiply. Sine theta over cosine theta would be tangent theta. 1 over cosine theta is secant theta. So the derivative of secant is tan theta, secant theta. And finally, we're going to figure out cosecant. Cosecant is 1, same thing as 1 over sine theta. So for our derivative, again, derivative of 1 is 0 times the bottom minus the top times the derivative of bottom, in this case is cosine, all over the bottom squared. So we've got minus cosine. I'm going to use one of the signs underneath it. The other one I'm going to write as its own fraction. Cosine over sine is cotangent theta. 1 over sine is cosecant theta. So the derivative of cosecant theta is negative cotangent theta times cosecant theta. And now that we know these, you do not have to show these ever again on your free response. If you can have them memorized, here's the problem though. If you tell me that the derivative of tangent is, say, cosecant theta squared theta, that's not going to help you. But if you can memorize it, you don't have to show the process of proving it to me each time. All right, find the derivative of each of the functions below by applying the quotient rule. All right, derivative of the top here would be 2x minus 2 times the bottom minus the top times the derivative of the bottom. What's the derivative of x? 1. Derivative of 2 is 0, so this is just 1 plus 0, so just 1. All over the bottom squared. So this would be 2x times x is 2x squared. 2x times 2 is 4x. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. And I've got minus x squared. Minus of minus 2x is plus 2x. All over x plus 2 squared. 2x squared minus x squared is going to be x squared. 4x minus 2x is 2x plus another 2x is 4x again. And then I got a negative 4 all over x plus 2 squared. And I think that's as far as we can take this one. Because this guy here does not factor, so we are done. All right, for this one here, p prime of theta, start with the derivative of the top, so derivative of sine theta is cosine theta, times the bottom, minus the top, times the derivative of the bottom. Derivative of theta squared is 2 theta. All over theta squared squared would be theta to the 4th. We would typically put these thetas out front, and I see that I got 1 theta. Well, let's go ahead and do this. Theta squared cosine theta minus 2 theta sine theta. Now, what do they have in common? They each have a theta, so I'm going to pull out 1 theta. I've got theta cosine theta minus 2 sine theta over theta to the 4th. And now this theta will cancel with one of these, so I just have 3 left. So my final answer for this one would be theta cosine theta minus 2 sine theta all over theta cubed. All right, that's it for this video, and there's some more to come on the next video.